Folks are trickling in. So hello everyone and welcome. I am Anh Bui, a passenger vehicle researcher at the ICCT. Thank you for attending today's webinar. Before we start, two housekeeping items. First, this webinar is being recorded. We'll also make it available on our YouTube channel in the coming days. Everyone has their microphones on mute. If you have questions, you can write them in the Q&A in the control panel. And after the presentation and panelist remarks, which will last about 30 minutes, we'll spend the rest of the time answering questions from the audience. And today, we are discussing the current automotive steel supply chains and the potential of green steel in mitigating the transport sector's climate impact. First, we'll talk about the relevance of the steel sector, followed by the presentation of recent steel projects at the ICCT, and lastly, remarks from our panelists. Our presenter today are Dr. Marta Negri, Associate Researcher at the ICCT, Dr. George Lucky, Manager of the Advanced Metal Technology Department at Ford Research and Advanced Engineering, Samuel Flückiger, Head of EU Climate and Circular Economy Policy at ThyssenKrupp Steel. Thank you all for being here. Before we turn over to the presentation, I will set the stage here on the importance of the steel industry decarbonization. So the steel industry is the highest emitting industrial sector, contributing approximately 7% of global greenhouse gas emission. Decarbonizing this sector is critical to meeting global climate change goals. According to the International Energy Agency, or IEA, emissions from steel production need to decrease by 25% by 2030 and by 90% by 2050 to align with the net zero scenario. More recently, research from Agora suggests that achieving net zero emissions in the steel sector by 2040 is feasible if all the stars align, such as the phase out of coal-based blast furnace by early 2040 and high deployment rate of greener alternatives, such as hydrogen-based steelmaking. However, these green steel technologies will require substantial investment to scale production capacities and infrastructures. So you can see I use this term green steel a lot, and many of you here attending probably are familiar with the discussion on what this term really means. And on today's webinar, we'll try to dive more into the complicated and nuanced nature of this term with the panelists. And to start us off, Marta will walk us through some of ICCT's recent works on steel. And just a reminder for folks, you can send your questions on the Q&A channel and comments on the chat channel. So yeah, take us away, Marta.
Thank you, Ayn. Hi, everyone. It's very exciting to present our research on steel. We have two papers. One was published earlier in July, and one has just been published today. So yeah, we've heard from Ayn that decarbonizing the steel sector requires a lot of upfront investments. And so that's where the steel users can come in and help take some of the risk investments out by committing to purchase a share of the steel that will be produced with new green technologies. In this sense, the automotive sector is an ideal market to uptake the fossil-free primary steel production. In fact, it is the second largest consumer of steel globally. It consumes 12% of steel demand at a global level, but 26% in the US and 17% in the EU. And also it consumes high quality, it tends to consume high quality, high cost steel that is typically produced with coal-based technologies. On top of that, steel-related emissions for vehicle production are consistent. And we have a figure here on the right side. Steel-related vehicle production emissions can be as high as 27% for internal combustion engine vehicles and 15% for battery electric vehicles. We've analyzed in the first of our papers the technology pathways to reduce steel emissions for the automotive sector. And we've analyzed 3 parallel strategies, one using fossil-free primary steel production technologies, as that will be the focus of today's discussion, but also increase availability of high-quality automotive-grade recycled steel, and using lightweight design, so using less steel overall in vehicles. As you can see in the figure presented here, the traditional coal-based technology, that is the bottom row, is the one that has now the highest emissions intensity, and efficiency improvements with this technology. So now I'm looking at the second to last row, will only get us so far in decarbonizing the steel sector. And what we really need to get to near zero emissions is shifting technologies. And in particular, the one that is currently commercially available is the direct reduced iron, or DRI, combined with an electric arc furnace. If we use green hydrogen and renewable electricity with these technology pathways, we can cut steel-related emissions in vehicles by more than 95%. And what's interesting is that these cuts can come at an increased cost for vehicles of only about 1%. So for the cost of about 1 to 200 euros for each vehicle more, we can have green steel. We've then analyzed in our second paper the supply chain of 17 key automakers in the European and North American markets. In this figure on the right, you see financial relations between automakers and steel producers in Europe. And in the arrow on the right-hand side, the estimated emissions intensity for steel producers that we've calculated. And as you can see, steel supply to automakers in Europe has a pretty high average emissions intensity. In particular, in this case, almost all are above 2 tons of CO2 equivalent per ton of steel. But this is true also global level. So the emissions intensity of the steel supplied to automakers tends to be above industry average emissions intensity in the regions analyzed. And this is because there's a lower use of scrap and recycled steel, and a tendency to rely on the coal-based technology. The same graph for North America. In North America, there is generally a higher share of recycled steel in the industry compared, for example, to Europe. But automakers also in this case tend to and have a higher than average emissions intensity, because again, for the same reasons, they tend to use less scrap overall compared to industry average, and use steel produced with coal-based technology. In this case, most of the selected automakers in North America procure from highly polluting steel producers. Shifting from a regional level to a global level, we've estimated also the automakers' average emissions intensity. The blue bars represent the central estimate, assuming that the automakers procure the steel from steel producers with their average emissions intensity. But we've also calculated the errors. So the error bars that you see represent a sensitivity analysis, assuming that automakers supply purchase steel with the lowest possible or the highest possible emissions intensity in all the regions where they have active production. So as you can see, the central estimate tends to be rather similar for automakers, around 2 tons of CO2 equivalent per ton of steel, but there is quite some uncertainty in the results depending on the assumptions related to supply. Finally, we have analyzed the commitments that automakers have made to procure fossil-free steel in 2030. And this goes back again to what we were saying before, that the industry can be a lead market for fossil-free steel production and help reduce the investment risk that is present in shifting technologies. Out of the 17 automakers analyzed, only 4 have at the moment public commitments to procure fossil-free steel in 2030. And these are General Motors, Ford, Mercedes, and Volkswagen. And if we sum up the commitments, the quantities of steel that are covered by these fossil-free commitments, these make up only 2% of the overall steel use out of the 17 automakers. So it's still a relatively tiny amount. If we also add up the reduced emissions intensity steel commitments, these make up another 2%. But in any case, this is far from what is needed to be in line with the decarbonization and emission reduction of 25% by 2030. Finally, so we've looked at opportunities for both the auto industry and policymakers to shift to fossil-free steel. Automakers, first and foremost, could demonstrate demand for green steel, ideally a 25% of fossil-free steel commitment by 2030. And this can be done by either signing pre-purchase agreements or joining industry initiatives. They could also increase the availability of high quality recycled steel by designing their vehicles for recyclability, and improve transparency by disclosing the emissions intensity associated to the steel they procure and recycled steel content that they use in their products. And finally, increase lightweight design to reduce the steel used overall. At the same time, policymakers can support this transition by providing subsidies for scaling up fossil-free steel production, introduce emissions trading system covering the steel sector, or incentivizing the use of fossil-free steel in vehicle production. And one example of policy measure that would be in this direction would be setting green steel quotas, or increase the circular use of steel and require vehicles to be designed for recycling, for instance, again, with recycled steel quota. We've provided links to the reports. You're very welcome to check them out. And I'm happy to answer any questions that you might have. And I'm looking forward to the discussion. That was all from my side. And I think I'll pass it back to Ayn.
Yeah, thanks, Marta, for walking us through the research and a lot of recommendations from the ICCT perspective. So now I would like to hand it off to our next panelist, George. We are interested in hearing your thoughts on this topic through the automaker's lens. Take it away, George.
Well, thank you for inviting me today. It's a pleasure to be here, and a good presentation. I think it shows it's very aligned directionally with where the industry is headed. Ford's sustainability strategy encompasses looking at the environmental, social, and governance impacts of both our tailpipe emissions as well as our manufacturing operations and our supply chain. Our supply chain is critical, and that's governed. We have a supplier code of conduct that sets expectations that also align to our sustainability ambitions for 2050. We have entered into programs like Manufacture 2030, which are helping set science-based targets for our supply chain, and so that they can cascade that down, which is very much what you're talking about, is how do you build a long-term roadmap, a glide path down, and really drive it from mine to, well, the finished car. It's a holistic approach, but even though it's a glide path, there's some low-hanging fruit. But what you're talking about today is sort of the higher up the tree fruit, which is harder. And we can't really wait to start working on that. It's a research topic, but it also needs to be an implementation topic sooner. So Ford joined the First Movers Coalition to create that market demand, to express that need, to really have breakthrough technologies and innovation in primary metal making. And so, but that is just, and what you're presenting today is just part and parcel to an overall long-term glide path down.
Yeah, thank you. Thanks, George. Glad to hear that you're joining a lot of coalition initiative to, to show your commitment to this future. So next we also have Samuel, and we have another perspective here. This from the steel supplier lens. The floor is yours, Samuel.
Yeah, thank you so much, and hello everyone. I see we have quite a few people online, so that's very good to hear. So the topic is of interest. I will just make a number of points, and thank you very much for the great research, which sheds some light on this very important topic. I'll maybe start with saying that the automotive industry is really a driver for innovation in steel making, and it has been for a long time. We have very close relationships with many automotive customers. In our case, we actually have a very high share of exposure to the automotive sector compared to other steel makers. And so we are also convinced that the automotive industry can be a driver for decarbonization as well, and help us on this journey along towards our shared goal of net zero emissions by 2050 at the latest. The second point would be that we definitely see growing interest for the topic of green steel. But at the moment, the willingness to pay the green premium, so the extra cost of having a green product, remains fairly low. So we see mostly voluntary commitments at the moment, and as was shown also by the chart which was presented here, the volumes that have currently been committed to are just not sufficient to drive the transition at scale in the steel sector. So there's definitely a gap there. And so yeah, that's something which in our view also has to be addressed policy-wise, and I'll come back to that. But maybe my third point would be on the fact that getting to near zero emission steel making, which is the sort of benchmark that was set by the IEA in terms of what would be required for the steel sector globally for being on a Paris compatible trajectory, is very hard work. And that makes a lot of sense, right? Because it was easy work, we would have done it already. But what I'm trying to say here is that the number also that was shown previously of 95% emission reductions in primary steel making, I think that mostly looks at scope 1 and 2. And even getting there is very hard, because it essentially means that you have to have completely fossil-free and decarbonized electricity and energy for achieving that. And that doesn't include the scope 3, which George also mentioned. So the upstream, the mining, the raw materials, so the iron ore, the lime, the ferroalloys, etc., which also have to be taken into account. So getting to this level of decarbonization really requires efforts across the board. I have a chart on this, but maybe I'll skip it for the interest of time. But therefore, it's also very important that we have a very clear definition of what we mean by green steel, that we have a comprehensive scope, which also includes upstream emissions. And yeah, so we have clarity about what we are talking about. Maybe then coming to my last point on recommendations, policy recommendations. So we very much agree with a lot of the recommendations that you made, especially on one point which is very important to us, which is the recommendation on disclosure to really empower the consumers and actors across the value chain. So that we very much support, and we have been making some strides at the German level with the low emission steel standard to do precisely that. We also agree with recommendations on circularity, especially those focusing on measures to improve the availability of high quality scrap, where we definitely some bottlenecks, and which is also especially this type of scrap, which is required for it to be suitable for use in high-end and demanding applications like in the automotive sector. However, another measures which we consider not to be very helpful is the one on recycled content for specific value chains like automotive, because in the absence of a comprehensive approach, this will just lead to resource shuffling between different value chains, because it's essentially a zero-sum game, right? There's only so much scrap available. So if we now have a recycled content target for the automotive sector, but not for others, we will see a shift from scrap going from some sectors which today already have a very high recycled content, like in construction products, for instance, where structural steel, for instance, which is already today made of virtually 100% scrap, to sectors like automotive without actually having an overall net benefit. So there, I think we have to be careful about the substitution effect and rather focus on enabling factors like better design for recycling, better sorting of the scrap, to have higher quality scrap with less impurities, rather than measures like recycled content. But I think I will leave it there, and I'm really looking forward to the discussion.
Yeah, thank you so much for sharing your perspective, Samuel. And thank you for all our panelists here for sharing your thoughts. So now we'll move to the Q&A section of the webinar. And remember, if you have questions, please write them in the questions box and we'll answer as many as we can. Okay, so I already see some questions to start us off here. One attendee already asked, and I think I personally also have these questions too. So you see that one of ICCT recommendation include that 25% of steel purchase would be green steel or fossil fuel free steel. We know that like different organizations and companies have different target at setting the definition of green steel, and like you already kind of allude to that in your remarks, Samuel and George. But I just want to like go through it again. Like, what does green steel really means to you? Like your company, your organization, just, you know, where you are at right now.
That's a very interesting question. So, unfortunately, I think in much of the discussion on this, it's too much of a marketing statement. Whereas for us, it becomes more of a technical statement of what does green steel mean. My opinion is that green steel represents the end game. That's what we're headed towards. And that what we're after is an engineered walk down to get to that. And so I want to be a little careful about calling something green steel or calling it a product. We're doing this as a supply chain, as a supply base together, all the OEMs and all of our suppliers. We have to be doing this together. I don't necessarily know that calling something green is helpful. What I do think is helpful is setting up, you know, robust accounting methods for how do we calculate it, how do we compare within our supply chains, setting targets and achieving those targets, so that are we on track to deliver our commitment. And there will be products in our portfolio that are, you know, our ambition is that there will be products in our portfolio that meet the near-term crude steel carbon intensity. We want that, and that's why we joined the First Movers Coalition. But it's in that case, it would be like 10% of our buy, and so it'll be a portion, but it won't be the whole thing. And it will be the first round of technology. Our expectation is continuous improvement between now and 2050 will make all this more efficient, and to address, you know, what Samuel's talking about, the cost aspect of it. We have a lot of engineering work to do to optimize this for scale and to optimize this to be competitive. Yeah.
You want me to elaborate on that as well? Yeah, very, very happy to. So I fully agree with George's visions. I think calling things green is not very helpful, and that's why yeah, as I mentioned, there's been some work by the IEA, and we've been building on that in terms of defining what green steel actually means. And so we prefer to talk about low emission steel and then near zero emission steel, which is the end game. I'm maybe just gonna share the chart which I have prepared because I think it illustrates a bit
I think that would be really helpful.
What we are talking about. So I hope you can see my screen now. There we go. So at the very bottom, can you just confirm that you can see the screen? Perfect. Okay. So this is the definition which was proposed essentially by the IEA. Here it's how it looks in the low emission steel standard, which has a wider scope. So the values are slightly higher, but the essence of the definition is the same. So at the very bottom, you have what is called the near zero emission threshold. And that is scrap dependent because there is only so much scrap available globally. And so on the right-hand side of the chart, you have 100% scrap-based production. And on the very left side of the chart, you have 0% scrap, so 100% primary production, right? And so for primary production, the emission thresholds are higher because you actually have to reduce the iron ore to iron, which you don't have to do for scrap. So that's why it was defined like this. And then above that, you have emission thresholds, which are just multiples of the near zero emission thresholds, all the way up to what today is basically the current sort of best available blast furnace technology. And what we have plotted here, and that's just to give you an indication, is where most of the BF blast furnace technology is today. So you can see that lands between 2 and 2.5 tons of CO2 per ton of steel. With the technology shift to a direct reduction plant instead of the blast furnace, we can already have those emissions if we run them on natural gas, or maybe a bit more by around 60% emission reduction. And if we run them on hydrogen, we can go further down. But there I would also use a word of caution, because even green hydrogen in most cases doesn't come with zero emissions. The EU definition for green hydrogen, a requirement is a 70% emission reduction compared to the fossil comparator. So that already comes with some CO2. So going further down and reaching near zero requires, as I said before, completely decarbonized energy carriers. But to really reach it, you also need decarbonization of the input materials, which are within the scope. So summing up, as I said before, it's a hard work and it's a journey, really. In our view, effective demand signals should not just focus on this near zero emission level, which is the end game, but cannot be achieved at scale in the short term. And so therefore, in our view, any demand signals, meaningful demand signals, in addition to things like the First Movers Coalition, which, as George mentioned, really focus on the cherry of the cake, if you want, but not on the mass demand, should also reflect the stepwise nature of the transformation. And so in our view, focusing exclusively on this near zero emission threshold as a demand signal is not very helpful in terms of really driving this stepwise transformation and reflect the stepwise nature of the transformation that we will have in the steel sector. So I hope that made it slightly more concrete, but yeah, and also addresses some of the questions I've seen in the Q&A.
Should I also go ahead?
Yeah, Marta, go ahead.
Thanks. Yeah, it's definitely a fascinating question, and it's very interesting to hear the perspective from the industry. I think it's very, very interesting, and yeah, it's a marathon. It's not a sprint, so we need to keep our eyes on the end goal. I'll just go back to Samuel's point on demand. There needs to be meaningful commitments and meaningful show of demand. With like in the graph I've shown before, 2/3 of the automakers we've analyzed don't have any commitment at all. So yeah, I guess shifting the industry and using this demand signal from the automakers could really make a difference, at least for these very first steps where investments are needed. And yeah, I just wanted to clarify again to a point that was raised before. We have included Scope 3 emissions in our calculations. But yeah, happy then to elaborate further if people are interested. So yeah, to keep things short, it's a very interesting topic. We do see a lot of confusion and a lot of greenwashing, again, to George's point. That's definitely not helpful at this stage. So perhaps going forward, a little more clarity and a little more concreteness when we talk about emissions intensity, understanding the scope and understanding what's included and what's not, it's really key, which makes it also a little more complex, I feel. So it's very technical, it's very detailed. So yeah, I can see where the confusion can come, but yeah, that would be definitely an area for improvement.
Yeah, thank you all your panelists for your thoughts on what green steel really means. Yeah, still it's very complicated, like what I mentioned earlier, very complicated, nuance, and we all should can work together to get that definition a little bit more honed in, right? My next question here is more towards George, and I see, like beside, I see like one of the attendee have these questions too. So beside like the cost, right? Cost and availabilities of green steel is one thing. What about the technical aspect? Like how are you, given that steel like produced by different methods, like hydrogen-based steel or like electric arc furnace, how do you ensure that like the material maintain the same strength or like safety property, and then the usage of recycled steel, like would it change any of like the properties of steel using vehicle?
I'll give two aspects of that. I'm from Ford Research and Advanced Engineering, so I'm from the Research and Advanced Development team in Dearborn. And one of our charters is, because we have a supplier code of conduct that mandates our suppliers cascade this information, that gives us a mandate to do research in the topic. And it gives us targets and guidance. And so that's been great. And so we have a number of university-funded, direct-funded university research projects, as well as projects leveraged with government funding, whether it be in the EU as well as especially in the United States, with universities and national labs looking at topics like, how do you do a better job of a more agreed to method of carbon footprint within our company, within our supply base and amongst our suppliers, researching better product recycling, researching how do we get more of that recycled product back into our metals, so how do we change the specs. So some sort of, not quite blue sky, but definitely more on the research side of how far can we push the limits conceivably, and then kind of walk back from there, what's realistic. Once you get to that pragmatic idea of we think this will work, we buy finished coils of sheet metal. Those are typically purchased from a supply chain that could be from any multiples of paths. So no suppliers have exactly the same process. They may look a lot alike, but they're not exactly the same. But we buy them to a grade or a spec. Typically, sometimes you'll buy like a brand name, but we try to avoid that. Typically, it's a grade or spec that can come from multiple suppliers, so multiple people can meet that need. The spec has the chemistry limits, property tolerances, dimensional tolerances for the thickness and width, the specs of the coil itself, the surface requirements. It's all the finished stuff, as well as expectations on upstream process, or where, is it hot rolled, is it cold rolled, and then downstream, how does it form, how does it join to other materials, painting, and durability, and then last, high rate fracture performance for like, impact performance. All that is really part of a material specification, and in some applications, a part performance spec. We have over 30 material specs for sheet metal, for steel, and we have about a little more than 10 for aluminum sheet. So there's a lot to manage. So when you change one supply path from one site code, there's a lot of grades that have to be managed. And if you do a new specification, it's a multi-year activity of development, from concept readiness to implementation readiness, with technical qualification to demonstrate statistical capability, all the way to full qualification of that the product path is scalable at the production we're going to do. Then there's intermediate levels of, if you modify a spec, which is actually a very detailed thing that we have to go through. But if you're working within spec, so if you change for lowering carbon intensity in a way that you're still working within the existing specifications that we use today, there is a process, and all companies have it, for managing that so that you can have a more efficient and a faster timeline. Could be a new product that goes on, could be a running change on a current product, but it's a managed process that's pretty regular in the industry, because as you can imagine, things change within plants at a regular basis. We want to know about it, and we want to facilitate making sure that whatever changes meets our needs. So there is a managed process for changes that stay within the specification.
Yeah, thank you. Thank you, George. This is very interesting. This is very like deeply technical, right? Like I feel like a lot of automakers also are trying to, like meet the specs, ensuring safety, but also want to push for this transition too. So my next question, I guess, is for both George and Samuel. Like, how do you really like working with steel, like with each other, really, to ensure the use of, more fossil fuel free steel, green steel, the definitions out there for in your vehicle? And then is there any policies that you would recommend? Like I think Samuel kind of touch on it, but also more, anything else that you think that can help create the demand and supply for this for primary steel, for the near zero emission primary steel.
How about that, Samuel?
I'm happy to start. Yeah, so as I mentioned at the beginning, we have very close and long-lasting relationships with many of our customers. And yeah, since a few years, we have been testing indeed also appetite for CO2 reduced products using a mass balance approach, because we don't have the technology shift yet. Yeah, so what we can do, we can take some additional measures in the existing processes to reduce emissions, and then allocate them to a share of products. So that's the mass balance approach, and then sell those emissions reductions at a premium. So that's our Blue Mint steel range. So that's a product we have been developing and using with customers, and we do see demand in some sectors. And it is also scaling up, of course. And in that context, we are also having discussions on and we have quite a number of MOUs, so memorandums of understanding, on purchase agreements for future products out of our future DR plant. And the good news is we have about half of our capacity already sort of subscribed through these MOUs. The bad news is there's no price attached to it, because of course that will depend on evolution of mostly energy prices, but also other parameters. So that will be the interesting thing, of course. So we do have some visibility, some predictability on volumes, but not so much on costs. That's maybe one important aspect to mention. And yeah, then I referred before to this low emission steel standard we developed in Germany. So that was precisely also, and that was a stakeholder process convened by the ministry here, but also with the involvement of off-takers, producers, civil society, to develop a standard which answered the needs and requirements of the actors along the value chain. So to really have a maximum level of transparency, including on a sort of decarbonization index along the scale I showed before, with these different levels on the way to near zero emissions, but also, and very importantly, recycled content, which is an important sort of metric, which also determines how you are plotted, of course, on this decarbonization index, and the product carbon footprint, right? Because this is a metric which already today, of course, plays an important role and will keep doing so going forward. So to really systematically provide the customers along the value chain with this information. So yeah, these are just a few examples of what we are doing, but we really do see the automotive industry as a partner on this journey. Absolutely.
Oh yeah. So we're following, science-based. We have science-based interim targets that we're tracking to, and in this space, that's going to continue to cascade into the supply chain, and it's sort of to measure our progress and to track it. And it is reviewed at the top of the company all the way down to my level, and in our research projects and our development projects, it's a topic for development to understand what can we do, what actions can we take now. Even if they're small actions that will reduce carbon intensity, and what ones have a business case. So we've talked a lot about costs, but they don't all cost something. There are actions that we can take today that begin that process of that reduction, and in some cases are more cost effective. And one of the challenges is tracking that. How do we track that progress and claim that progress and show that within our own company that we're doing that? And I think that's a challenge going forward. We're very good at tracking dollars, but we're still learning how to track carbon. So I think within our company, there is a framework in the science-based methods that is going to support us a lot in this, but we're still evolving in how to do that and then how to cascade it. But it's very much an engineering and a procurement strategy optimization team sport of how do you manage performance, the scale of production, the cost of production, and now sustainability. And it's an exciting time.
Thank you. Yeah, for sharing your thoughts here. Seems like a lot of moving pieces getting there. So I think this one, the next question here, I'm trying to see, it might be a curveball here, and you might not have an answer to, but I'm just interested in seeing what you've seen out there. So we talk about steel premium for steel buyers. How about how about for car buyers? Like, could the auto industry make it a marketing angle? How ready do you think the consumers are ready to pay such a premium? And what do you see so far? Or like, is there any marketing strategy being developing?
Yeah. Well, we had an ICCT, a panel discussion in the summer, and a similar question came up, and really, I think that consumer sight to this, it's not a major part. It's not on their radar, I don't think yet. I think your work is going to hopefully, that can help elevate it, and I think it does need to be elevated. But there's a few articles, but I don't know if people read those articles out there in the sort of common literature and just journalism. But it's not a major topic of our consumers. We're still we're focused heavily in our marketing campaigns on EVs and moving that business along. This is part of that, definitely part of that. But the manufacturing side has it's something we've talked about. We put it in our reports. I don't have a good sense that it's a strong marketing topic.
Maybe if I can chip in on that. I like to use the analogy of the CO2 emission performance standards in Europe, or the miles per gallon, rules you have in the US, which didn't used to be something the consumer was necessarily very interested in when purchasing a car, but became something he eventually was very interested in, because there were all kind of benefits attached to it, like tax breaks, you name it, lower registration fees, whatever. So I think we also need to think about clever ways of making the embedded emissions in the car and the footprint of the car something the consumer cares about, right? Because there's only that share of consumers which are interested in it for intrinsic reasons, I think, but there are ways to make the consumer interested in it. So there definitely a strong role for policies to send signals which incentivize the consumers to go that way, and which eventually reduce that cost premium, right? There are ways to offset the cost premium through tax incentives or other measures. Some systems we had in France, for instance, bonus écologique for the cars, these kind of things, that precisely goes into this direction. Not very helpful at EU level, because as you know, fiscal policy is not a competence of the EU, so that's mostly a national prerogative. But nevertheless, I think this is the sort of way we need to go, and we achieve the end goal, which is that the consumer actually is interested in buying a low emission car, embedded emissions car, for certain reasons. Then I think we go a long way and that will then trickle down along the value chain, manufacturing value chain, all the way to the upstream. And ideally then all the way to the mine, which is really what we have to look at.
Maybe I'll also chip in for this one. Because maybe to add a perspective, we also see the same, like there's not a lot of interest so far in the general public about steel. It's a relatively niche topic. And I get George's comment that it's already hard enough to make them care about electrification in the first place. But maybe, so we've seen from a lot of angles and research that the final cost for consumer would not be that much. So probably the cost, or another perspective that we have, is that this premium cost could be just shifted to consumers, and it would be just a couple of €100 more. So maybe that's also a possibility, that it keeps being a niche topic, and the consumer doesn't need to know all the details of steel production and steel emissions, and perhaps they would just pay the premium, or like they can absorb the premium in this sense.
Yeah, thanks for your perspective here. This, an interesting one to see, like we have to balance, how much we push the consumer and how much, is get absorbed by automakers. I think we're at like the 50 minutes mark, so I think we have room for one or two more questions. One of the questions I think I see a lot in the Q&A here, and it's also another question of mine. You kind of mentioned it a little bit in each of your remarks, but what do you think are the challenges, like the main challenges from your perspective? For example, how do we overcome like the green premium? Like how, or like from ICCT perspective, what are the challenges to steel industry decarbonization? So each of you have your own, kind of lane, but I'm interested in hearing your perspectives.
I can start. I believe that that we, our competitors, and our supply chain, which we have a common supply chain, need to move together. If there's not a marketing tool where a consumer says it's a must-have thing, which would be great if that was the case, by the way, we all in on that. But if it's not, then we have to, as an industry, move together and move our supply chain together. And no one supplier, no one OEM can do this economically alone. That way we're competing in the same economic space. And that actually drives competition with respect to economics. We will get this in the box. It will happen. There's wonderful engineers around the world working on this. I think that once as you do that, it's managing the transition in a way that does not cause a constraint. So, changing over one plant is one thing, but what happens if that one plant goes down? Can you easily go to another plant? You have to have supply chain redundancy. We don't want to you don't want to implement technology that's not scalable, because then it will not serve and be fit for the purpose. And I think that's one of the biggest challenges is developing and implementing technology that is scalable and robust for 50 years. That's what all of us in manufacturing strive to do. And many of these technologies are in their infancy that we're sort of referencing. Some of them are not, but some of them are. Especially when you have to make big moves in primary metal making. So.
Shall I continue? So yeah, maybe beyond this sort of signals across the value chain, which are indeed very important, I would maybe highlight the issue of energy and the need to drastically scale up renewable energy deployment and the availability thereof, because steel production is very energy intensive. And so, of course, we need a lot of renewable energy to power those processes. Another issue, which is quite a thorny one, is the problem of overcapacity in the steel sector, global overcapacity, which is huge. Today, it's over 600 million tons. That's more than the combined capacity of the US and Europe together. And that's predominantly on the energy-intensive conventional blast furnace route, right? And that means that it pushes prices down, and it means that as long as there isn't a level playing field, you have a lot of these products flooding the market at very low prices. So that is definitely a big problem as well. And maybe the last point, and I think that was the whole point also of the discussion here, is that we've seen a lot of policy focus on the supply side so far. Now I'm talking about steel, so the supply side of steel in terms of funding, emissions trading, etc. I think over 80 or 90%, there was an overview, I don't remember by who, that was done, that showed that about over 90% of the policy emphasis so far has been on the supply side, with subsidies, which is needed, right, for the first wave of decarbonization. But that cannot be the way to finance all the transformation. And so therefore, I think we really also have to need to look at the demand side of the policy framework and have demand side signals, which really will also drive the demand for those low emission materials, which initially will be higher, but will become the norm in the long term.
Yeah, and we'll maybe just a very quick thought on this, just to reiterate that we often see this kind of chicken and egg problem that automakers don't commit because there is no green steel, and steel producers don't produce because they say that there is no demand and things like that. So maybe that is why, or where policies can help in this sense and try to create like equitable conditions and like provide that investment security that is needed for to deploy the investments that are needed to decarbonize the steel sector and production.
Yeah. Thank you. Yeah, thank you to our panelists here. So I think one last questions, I think, if before, we close, we have about 5 minutes. If you can say, one thing that you like to see in the policy side in the next, year, the next 3 to 5 years to succeed, what would it be that would be able to help move the green steel transition?
Yeah, I'm happy to start. So I think, building on what I said previously, I think it's policies on the demand side, right? Sending some signals. And I think the obvious place to start there is public procurement, because governments will be looking for ways to move away from subsidizing the transformation, and should also be walking the talk when it comes to the transformation of the steel sector. But then also beyond, right? I mentioned before, we discussed here, and I think ICCT also recommended green steel quotas. That's certainly a possible measure. I referred before to things like tax incentives or others. So I think there are a lot of possible measures that can be taken to drive this demand. Also minimum product standards at the EU level, I think that certainly has an important role to play in terms of setting expectations going forward with increasing level of ambition over time. So yeah, I think a combination of sort of push and pull instruments also on the demand side can really play an important role here as well.
I think I don't speak for policy, but anything that can drive sentiment and interest in this activity, in decarbonizing metals to our consumers, and make our products, because of that, be more valuable to them, be more exciting to them, it would be a wonderful thing.
And Marta, do you have? Yeah, I'll just restate. A combination of policies probably is what we would say would be best. So yeah, maybe a combination of green steel quotas or recycled steel quotas. We definitely get the arguments against the more recycled steel quotas, but yeah, perhaps a combination of measures and policies is something that could be well suited for the transformation that is needed. We don't hear you anymore.
Yep. Thank you. Yeah, thank you so much, everyone, for a very exciting panel. We have a lot of work to do, right? With material side, policy side, demand side, supply side, all of that together. So thank you for everyone for participating in today's presentation. And please don't hesitate to reach out to us if you have any further questions. And remember to follow us on social media channel and subscribe to our newsletter if you haven't yet. And thanks again. And I hope to see you all soon. Thanks so much to our panelists here. It's a wonderful conversation.
Thank you.
Thanks for organizing.
Thank you.
Thank you.